our eminent presenter, Mr. M.U. Ramanathan, Director, Structures, Transit and Railways at AECOM. AECOM is an engineering consultancy firm with global network of experts. Mr. Ramanathan is trained in AECOM's Hong Kong office for over 2 decades. He is a postgraduate in structural engineering and a member of the prestigious Institution of Structural Engineers, UK, and Institution of Civil Engineers, UK. He is a registered professional engineer of Hong Kong and a chartered engineer of UK. He has had experience in design, construction, supervision, and contract administration. Mr. Ramanathan's projects have involved metro rail works, medium and high-rise residential office, hostel, and commercial buildings. His experience has also involved viaducts, cut and cover structures, and formations, roads, and drainage works. He was involved in several Hong Kong metro rail projects. This include the detailed design of West Rail and Lohas Park and preliminary design of Chatham Central Link, South Island Line, and West Island Line. Between 2009 and 2014, he led the tender design for the Phase 1 of the Chennai Metro Rail stations, numbering 32, and its depot, and has subsequently overseen its design and construction. He has also worked as the lead civil engineering design manager for the Riyadh Metro project and project manager of the Mumbai Coastal Road project. He is also working as the project manager for the detailed design consultancy of one of the 3 corridors of the Chennai Metro Rail Phase 2 works. Mr. Ramanathan had completed a study on design work commissioned by the City University of Hong Kong as a part-time research assistant. He has published technical papers in peer-reviewed journals and has also given talks in various technical forums. He is nominated as an assessor for the Hong Kong Institute of Engineers and Institute of Structural Engineers, UK, for their chartered membership examinations. He also writes occasional articles in Tamil newspapers.
Good day, friends. I am very pleased to meet you in this Digital Rail Technology Expo. So we are talking about expansion of metro systems in India. So the metro systems in India started in early 2000s and it has picked up very fast. Today we are going to talk about generally the metro systems and systems in India and the advantages of going for an underground metro, and specifically some of the design and construction features of the Chennai Metro, all within 15 minutes. So I have divided today's presentation into 3 parts. First part is about metro rail in general and the city of Chennai and its metro rail. The second part is underground station, why we should go for underground and what are the merits and demerits. And the third part is tunnels. So the underground metros, there are stations at every regular distance of 1 kilometer or so, and they are connected by the tunnels. So we'll talk something about tunnels as well. And the first part is metro rail and Chennai. Basically, let us go through how metro rail is different from the normal intercity railways, because we have been using the intercity railways or the mainstream railways for very long. But these metros have picked up only in the last 15 to 20 years in this country. So let us just brush our memory on the basic differences. The metro rail runs by name, it's clear only in the metro cities, and it's used for mass transit. So in Chennai, there are 4 cars trains are there, as you see in this picture. A 4-car train is capable of transiting 1,276 commuters at a point of time, whereas even a bus in this city can take about 70 people, 40 seated and 30 standing. So you can imagine how many buses we would need to replace a single 4-car metro train. So it is used for mass transit. And another thing is the stations are located very close. normally 1 kilometer. That is, the idea is anyone along the alignment in the city, by walking not more than 500 meters, he or she should be in a good position to board a train. That is the idea. And in metro, we use standard gauge. What is the standard gauge? Indian Railways were originally running on meter gauge, as name indicates. The distance between the two rails is 1 meter, and it is all replaced by broad gauge now, which is up more than 1.5 meters. And the standard gauge is something between meter gauge and broad gauge. To be precise, it is 1435 millimeter. Why we should have a separate gauge for metro? Because metro rail run in the cities where there are sharp curves, and the rolling stock, or what we call the train, that should run or maneuver in sharp curves. So that is for that the standard gauge is suitable. So the rolling stock means nothing but the train cars. And the signaling and telecommunications are also very much different from the normal trains. And headways, what we mean by headways is the time distance between two successive trains. So I said the metro stations are normally 1 kilometer apart. They are very close. Similarly, they run very fast. I mean, the time gap between two successive train is also very less. In the city of Chennai, now in the peak hours, the distance, the time gap, or what we call headway, is 5 minutes, and non-peak hours it is 14 minutes. In cities like Hong Kong, where I was trained, it is even 2 minutes in the peak hours. So the Chennai metro, or that factor, all metro rails in India designed for such a headway. So if required in future, the headway can be reduced, and the train system, signaling, telecommunication, everything is designed for that. And another one is this TVS. What is TVS? Tunnel ventilation system and ventilation and air conditioning system. That is all a new and specific for metro rail operations. And the loading of the metro rail trains on the rails is also much different when compared to the broad gauge mainstream railway. Now, the merits of metro rail. We all generally know that it consumes very less energy, and it is more reliable. There will not be any traffic jams, so that will be punctual and lesser noise level, and it is very comfortable. Travel in air-conditioned coaches, so you will not be subjected, the commuter or the passenger will not be subjected to heat and other inconvenience, so that he can go to his workplace in a very good mood. And the capacity can be augmented, means for example, as you see in this picture, this is taken from the Chennai Metro, which comprises 4 cars, but it has been designed for 6 cars. The stations and signaling, telecommunication is all designed for 6 cars. So whenever it is required, because these are all designed for a long period, 120 years of design life, so it can be augmented to 6 cars whenever it is required, and the journey time is reduced, and it's faster, carbon emission is less, and it carries same traffic as 7 lanes of buses and 22 lanes of private cars. So there's a lot of merits by going in for metro rail. So now coming to India, so all over the world, metro rail has been very popular, but if you consider India, it all started very late. But actually, in the Calcutta Metro, it started very early, as early as 1972. But what happened, the method of construction used was not very modern. It was an underground metro. Nowadays, we have what we call bore tunnels. The tunnels can be bored underground without disturbing the strata above ground. So that type of technology has not developed or not well disseminated downstream. So the Calcutta Metro used the conventional method, what is called cut and cover. That means you cut open the earth. So now the stations are constructed by that way, but tunnels are bored. So in Calcutta Metro, they constructed both tunnels and stations by this cut and cover method. And in those days, the communication, the interface between various government agencies, various utility companies were not very good, and all that delayed the Calcutta Metro, and people were subject to a lot of inconvenience. And in 1984, after solid 12 years, they could complete or inaugurate only 3.5 kilometers of underground metro. So the experience of Calcutta Metro made other cities not to venture into the metro rail. But everything got changed in the year 1998 when Delhi Metro started. And Delhi Metro, the first phase commenced in year 2002. And Delhi, the city, the capital city, first time saw a train within the city. The cities like Chennai or Mumbai have suburban trains for very long, from British period onwards, but Delhi didn't have any. So the Delhi people embraced metro rail, and it was a grand success. Now Delhi has nearly 225 kilometers long metro rail with 160 stations, one of the longest metros all over the world. So the success of Delhi Metro made all other big metro cities. So the Calcutta and Chennai started in 2009, and Mumbai started very soon, and Bangalore, Hyderabad all followed. So these cities, Delhi, Mumbai, Calcutta, Chennai, Bangalore, Hyderabad, are called first-tier cities with a population, a very big population. But later, Government of India also allowed, the Ministry of Urban Transport also allowed that second-tier cities to have metros, and most of these second-tier cities did go for elevated because that can be constructed very fast, and relatively it is cheaper than underground metro. So many second-tier cities, Kochi, Jaipur, Ahmedabad, Lucknow, Kanpur, Chandigarh, Nagpur, Pune, Noida, Agra, Indore, Patna, all these cities, all these places now metro rail constructions are going on. So the metro system has well taken off in our country. So this is a map of Chennai Metro. I'm going into the details. This is the first phase, which commenced in 2009 and completed in 2016, but in between it's done in phases. So this total 45 kilometers, out of which nearly 50% is underground, what is shown in the shaded line, the purple color, and the blue color is elevated. So there are two corridors, and so this is the mammoth phase 2 of Chennai Metro, which comprises of 119 kilometers, and several underground stations, and more than that, elevated stations as well. What you see in blue color here is the phase 1, and also green color. These two are the part of phase 1. So this is an extension of phase 1 from a place called Washerman Pet to Vimkonagar. This was just inaugurated 10 days ago by Prime Minister Modi. And this is also now in operation, and this is a grand success. And a lot of, because this is northern part of the city, this is the North Madras, what was called, was relatively less developed than the central part of the city and the southern part of the city. So this is the first time a metro is passing through all the small suburban places of the Northern Madras, and there is a lot of enthusiasm among the citizens. They have embraced. And what you see mainly here is the phase 2, the 119 kilometer. It comprises of 3 corridors. So corridor 3 is this purple color, 45 kilometer. Corridor 4 is 26 kilometer, and corridor 5, shown in red color, is 47 kilometers. So this total 119 kilometers has been divided into 17 civil tenders, and all the civil tenders have been launched. And 2 of the tunnel tenders have already been opened, and other 15 tenders have been launched. So what has been now shown in the purple thick color highlighted, one is underground, and the remaining part is so these are the different stages. The detailed project report for the phase 2 was completed in 2015. The geotechnical investigation, the client themselves did the geotechnical investigation. Very expansive geotechnical investigation was completed in 2018. The detailed design consultant, that is AECOM, is doing the entire corridor 3. So the other consultants doing corridor 4 and corridor 5. AECOM is also doing part of corridor 4. So these are the detailed design consultants. They were appointed in 2018, and detailed design work is completed in 2019. And a general consultant for project execution, that is construction supervision and contract management, was appointed in 2019. Tenders are floated in 2020 and 21, and construction contracts will be awarded starting from 2020, and the works will be completed in phases between 2025 and 2026. And before going to the underground, I just want to show a 3D view of an elevated metro along OMR. What is OMR? Is Old Mahabalipuram Road, the road from the city which leads to the historical place called Mahabalipuram, where Prime Minister Modi and the Chinese President Xi Jinping met 2 years ago. So this is that road, is a famous road of the city which is called Old Mahabalipuram. And you can see that there is a viaduct below. This is a proposed road, elevated road, and the train, the metro rail will be running above. So this is another cross section, a closer view. So this is the existing Old Mahabalipuram road, now called Rajiv Gandhi Road, and this is the elevated viaduct, proposed elevated viaduct, and this is the station side platform. The trains will be, the platforms will be opposite to each other. And here is another place where there will be 2 decks of elevated viaducts. One elevated road and another one at a junction where there is going to be a flyover and over which the stations are constructed. So all provisions, the station will go first, but provisions will be made for the elevated road, which will come later. And now I go into the underground stations. So this is a typical underground station. So where you can see it's a big box, constructed below ground and with tunnels on either side. So the underground metros are there everywhere, all over the world. The London Metro, which is popularly known as Tube, is the first one, which started in 1863, and now it has more than 400 kilometers of metro, or with nearly 270 stations, and on an average 40 lakh journeys are performed every day. And Paris Metro followed in 1900, New York Metro also in 1904. And that is a city, US is not very popular for public transport, but the city of New York has this, what is called a subway, is very popular. And then all over the world, that has the maximum number of stations, nearly 424 stations in New York. And Tokyo Metro came in 1927. Moscow, actually it is a piece of, what I would say, every station has been constructed so meticulously like a museum, and with a lot of heritage value. Because of this communist policy and Iron Curtain things, many people were not knowing about the developments in Moscow for long. So anybody have an opportunity, they should visit Moscow Metro. And Beijing Metro started in 1969. And all over the world, there's a maximum number of people who are using metro in Beijing. That is nearly 1 crore journeys per day. And Hong Kong Metro, where I was trained, started its operation in 1980, Singapore in 1987. And Shanghai Metro, though it started very late in 1993, today that has the maximum length of metro rail all over the world, nearly 644 kilometers. Now, all over the world, people use, as we see, underground metro. Why? Why should they go for underground? And as I said before, in India, most of the second tier cities and even the first tier cities go for elevated for economical reasons. The cost is less, and the inconvenience of the city citizens or the city dwellers at the time of construction is relatively less in elevated metro. Underground, it is a bit of nuisance during construction, and it is expensive and it takes longer time. So that is why our people are going mostly for elevated. But why all over the world, all the major cities go for underground? Because the underground metro is more sustainable. It is not damaging the configuration and the landscape of the city. Because I can compare the Mount Road of Madras or Chennai and the MG Road of Bangalore. Now MG Road of Bangalore as a elevated metro, meaning the landscape of the city of the MG Road has totally changed. You are having an eyesore sort of viaduct in the middle of a very important road of the city. Whereas in the Anna Salai or Mount Road of the Chennai city, which is the lifeline of the city, all the metro stations are below ground, underground. So the whatever structures, road width, commutation, passengers, all the heritage structures, because it is a city with a lot of history. Around Chennai Central Station itself, there are many heritage buildings. RIPON building, where Corporation building is there, Town Hall building, Victoria Hall, and the famous Chennai Central Railway Station, one of the first railway stations built by British, and the Chowdhury, which is called Ramasamy Chowdhury, which is now used by Government of Tamil Nadu as a tourism department's hotel. These are all heritage buildings on either side of the Punamalli High Road. And the Chennai Central Station has been built underground. That means all these heritage buildings have not lost their views even after construction of this metro. Had there been a viaduct in the middle of the road, all the view and the importance of this heritage building and the city's history, culture, the look, all would have been lost. So underground, that is not the case. And it does not harm the biodiversity, and the existing road traffic is not affected, because in elevated metro, you built a pier in the middle, and the road width is reduced. And whereas in the underground, whatever traffic, we are pushing a lot of traffic in below the road. Otherwise, they would have been traveling in buses or cars or scooters above the road. So all their carbon emission is all now saved. So they are going below ground, so it is not harming the environment. These are the broad advantages of underground. And now I quickly go into the construction techniques. So the underground, if the soil is good, you can go for open excavation, but not in many places. And places where the soil is loose, you have to use some shoring system or some other system. Shoring system is a vertical support, temporary vertical support to support the excavation. Places like Delhi, in the top portion, you don't need any shoring, but below you need. Mumbai is also same. And in the places like Middle East, where the soil, you don't need anything. You can just go down 25, 30 meters without any problem. But in the Chennai city is not very advantageous in that way. So where we use something called diaphragm wall, because the water table is very high. So it is not economical to use temporary shoring system. Can be used, but instead of temporary shoring system, what is used is a diaphragm wall, is a concrete wall, which will be constructed by like something like a bow pile, by pouring concrete from the top. It will be used as a temporary support during the temporary construction stage, where you see a lot of steel struts longitudinally and on the other transverse directions. But once these are all removed, this diaphragm wall, which is built for temporary, will become a permanent support. So this is all, again, another view of diaphragm wall, where you can see steel struts. And we have to do an extensive soil investigation to understand the soil conditions. So go for 30 meters, 40 meters below ground, take the samples, and geologically design your diaphragm wall and the bore tunnels. That is very important part of the underground construction. And this is just a cartoon. I don't want to go into too much detail of a structural design of a diaphragm wall, or for that matter, any retaining wall. What you see in the first number one is wall. The diaphragm wall is constructed first. It is excavated in the top portion, and some first strut is provided. Then you excavate further down, and then number four, you provide a strut, and number five, you go down further, and then you provide this final. You come to the bottom level. So as you could see, the performance of this wall, this is all exaggerated, the deflected shape, but you see every single stage it is not the same, meaning the designer has a big problem. There is no one single condition. If you construct a simple building, the walls and slabs and beams, you know what is the maximum shear force, what is the maximum bending moment. There is only one case, the maximum load case. But that is not the case with respect to a diaphragm wall or for a retaining wall, especially in this type of deep underground structures. So every single stage, the performance is different, and you have to check every single stage, and you have to design in such a manner that it withstand all pressures for all stages. So this is a plan taken from one of the metro stations in the city of Chennai. So what is shown in green color is diaphragm wall, and what is shown in blue color is a column in between. This is a plan view. This is how D wall is constructed by diaphragm wall. That is what is shown in 1 and 2. I have taken this from a brochure of a trench cutter manufacturer. So it is cut, the trench is cut, and a temporary solution called bentonite is filled in. That will hold the excavation temporarily, during which you insert the rebars or reinforcement and also the concrete. So this is a very elaborate process, and not many contractors can do. So you need a lot of equipments, and you need a specialization in doing this diaphragm wall. So these are all some more cartoons, how it is done. It is all cut into small pieces. So the first one is showing some guide wall, and the second one, it is cut in 3 bits, and reinforcement after 3 bits. You hold for the entire thing, normally about 1 some meters, 1.5 meters, 1.8 meters, like that, and the real bars is reinforcement is inserted, and concrete is poured. Sorry. So these are the pictures. So what you see in the left side is the trench cutter, and on the right side is what I talked about, the guide wall. It's just going down, and this is a reinforcement cage of a diaphragm wall. What you see, the planks at 3 levels is for the 3 stages, 3 slabs. So the top slab and the concourse slab, where the commuters will be coming and buying the tickets, and then go down to the platform level where the trains are there. So all these 3 levels, you have to put the rebars to the couplers for rebars of the slabs to connect. So it's a close-up view. The reinforcement is pushed in, and this is concreting. So this is how a diaphragm wall is constructed, and this is a photo taken during construction of the Chennai Central Station, a 4-level station, very complicated station. And I was talking about the heritage building. What you see there on the right-hand side in white color is a RIPON building. Is more than 100 years. So some renovation work was also going on at the same time. You could see that also. So you can see all the reinforcement bars left out, and the traffic has been diverted. Part of the road has been taken by the contractor for construction, whereas the remaining part, the traffic is going on. So this is what I call the disturbance or nuisance to the public during construction. There is a lot of utilities to be diverted, a lot of traffic to be diverted. But once you construct it, so the station will go below ground, and it will last for 120 years. So this is another underground station, also from Chennai. So this, I don't want to go into the details. So this is what you call top-down construction. So the diaphragm wall, and then the struts, and you can see also reinforcement. The slab will be cast first, the top slab, and then excavation will go further down. So first slab will be cast first, second slab first, and the third slab later. It is called top-down. There is also another method called bottom-up. We excavate everything down and build from the bottom. So very quickly, I'll go through the bore tunnels. The bore tunnels are tunnels which are connecting the two stations. So normally, these twin tunnels are 14 meters apart and average 6-meter diameter. To be precise, it may be 4.8 or 5.7, something like that. It was a big thing when it started in 2000, but now after 20 years, Indian contractors and Indian engineers are very familiar with bore tunnels. It is normally 1.5 times the diameter, that's 9 meter, 6 times 1.5 below ground. But if situation warrants, it can also be above, but you have to treat the ground. So this is a tunnel which is showing what we call technically space proofing. That is, everything will fit into it, and the train should not touch the kinematic envelope what you see all around, and all the cables, ducts, drainage, rail support things, platforms, everything will be accommodated within this 5.8 meter or 6-meter diameter tunnel. So how this is bored? This is called a closed phase TBM. So this is called, or TBM is a tunnel boring machine. So this machine bores through and it is closed in the front. So this and how it operates inside, there will be a screw conveyor. So there will be a lot of pressure on one side, what is shown in blue color or green color on this side. This is the water table, so this is the water pressure, and there's a soil pressure, or everything, this is the soil pressure. So all this are acting towards that, and the machine from inside will be giving an equal and opposite pressure to withstand all this big pressure. And it rolls around, and the soil will be excavated and taken through the screw conveyor and back to the tail of the tunnel boring machine. So this is a more clear cross section. So this is the front face. So this is the screw conveyor taking the soil or the earth out, and that will be first stored here in this chamber and then taken inside. And these are the segment linings. So what you see here is the concrete segments. So the entire circle is divided into normally 6 pieces, and different sizes of segments will be there. That will all be brought and then fixed in position. So the machine will do everything. And this is a gasket for all these joints to be connected. So you can see the finish of this tunnel, the tunnel segments. So this is a photo taken from a stacking yard. So very big area is required where the concrete is prepared, and the segments are cast. So this is a batching plant within the casting yard, and this is where the segments are cast. So these molds are very expensive, and you can see the rebars inside, and the concrete is poured in different sizes of molds, segments. So all put together will form a circle. So this is a segment transportation, and this is how it is. The segments are connected together. And this is a station. So this is the tunnel boring machine. So from here, it will start working. It peers through the wall and then goes out of the station box. And this is a photo. From one station, it will start, and another station, it will break and come in. And again, it will start from next station to the following station. So the tunnel boring exercise, India has very well practiced, and now there are a lot of Indian contractors, and Indian engineers are also very familiar. So it has been in operation for nearly 20 years in this country. So the underground metro, so we have come to the end of the presentation. There are a lot of inconvenience during construction, but when compared to elevated metro, it is more sustainable, and India is very well taken off, and a lot of cities have already started working on metro, but most of them are elevated. And I wish a day will come that the future metros, more of underground will be built. Wherever the city has not developed, the suburban where you have a lot of land, where I was showing a picture of OMR in Chennai city, very wide road, 40-meter wide road. So there you can go for elevated metro. But wherever the streets are narrow and wherever it has heritage value, wherever you don't want to touch the configuration of the road traffic, it's always better to go for underground metro. And, gentlemen, thank you for your patient hearing. That is the end of my presentation. Thank you. Thank you very much.